Hello, my scholars. This is Miss Miller. I'm here to show you how to figure out how to use the segment and the angle addition postulates. So the goal is to be able to use the segment addition postulate and angle addition postulate to solve problems. The first thing you have to understand is that a postulate is a statement in geometry that we accept as true even though we don't have proof. Sometimes there's things in geometry we just have to accept because there's no way that we could prove every single case. But when you see them, you're going to realize that they're kind of common sense. So for example, segment addition postulate means that if we have a line segment and there are points on it labeled A, B, and C, A, B, and C are collinear points. If B is between A and C, you can see it's in the middle there, then the segment AB plus the segment BC will end up equaling AC, the total amount. That makes sense, right? If you add two things together, it's going to give you the total. I'm going to go ahead now and show you how to use this postulate in a real world segment problem. So the first thing that we have to do is we need to here solve for x. I know that there are 3 segments here in total. So if I add NM plus ML plus 2x minus 19, which is LK, I should get my total amount of 23. So here we go. I'm going to go ahead and add them together. NM plus ML plus LK will equal my total of NK. So now we're just going to go ahead and substitute them back in. NM is x minus 6, ML is positive 9, LK is positive 2x minus 19, which equals my total amount of 23. I'm going to find my like terms, so I'm going to circle my variable terms, which is x and positive 2x, and I'm going to circle my constants, negative 6, positive 9, negative 19. I always tell you to draw that line down the equal sign to keep yourself straight. And here we go. X plus 2x, we know there's an invisible 1 right there, so that gives me 3x. Negative 6 plus 9 minus 19 is 3 minus 19, which is negative 16. Drop down your equal sign, 23. The left side is simplified, the right side is simplified, so I'm going to use my inverse operations. Add 16 on both sides. That cancels out to be 0. Drop down my 3x equals 23 plus 16 is 39. Inverse operation of multiplication is division. Divide both sides by 3. 3 divided by 3 is 1. And I'm left with x equals 39 divided by 3 is 13. You would think we're done, but the goal was to not solve for x. It was to solve for each of these segments, okay? So NM is x minus 6. So x minus 6 is how much? I know that x equals 13, so if I substitute in 13 for x, 13 minus 6 is 7. So 7 is the distance of NM. ML, I already know, is equal to 9. And LK is 2x minus 19. So I need to substitute 13 in for my x by using my parentheses. 2 times 13 is 26. 26 minus 19 gives me 7 also. And 7 is then the distance of LK. I always like to triple check my work because if I add all 3 of these segments together according to the segment addition postulate, it should equal the total of 23. Does 7 plus 9 equal 23? 14 plus 9. And yes, 23 equals 23, so that's a true statement. So the segment addition postulate works. Go ahead and pause the video and try example 2 on your own in your notebook.